Hi everyone. In this short lesson, I'm going to demonstrate how we could use something like Microsoft Excel to help us with repetitive calculations. In this case, areas of triangles using Heron's law. So I've got here a blue and a red triangle, and I know the coordinate points for the vertices on each of the two triangles. I'll start with the blue one first. I have just generic point 1, point 2, point 3, and for the first point, I've copied the values of coordinates for A, then for point B, and then for point C. Now this is where the fun begins. I first have to calculate the distance for each of these edges. So where I've got little a here representing little a, this distance, that's the distance between point C and point B. So our distance formula, here we go, starts with an equals, SQRT for the square root, open brackets, open another set of brackets. Now I'm looking for the difference in the x coordinates of point C, subtract point B, close brackets, and squared. Now add on another set of open brackets, difference in the y coordinates, subtract that y coordinate of point B, close brackets, squared, and then close brackets once more, which is the square root bracket. Be very careful that you've got that correct. That gives me a distance 4 between point B and point C. Makes sense, doesn't it? Now I'm going to do the same formula in here, but I'm going to have to, I can't just copy, I'll have to code this one. Here we go. Now for edge B, that's between point C and point A. So that's the third point and the first point. It'll be this one. Take the x value squared, then the difference of the y values squared, and then close the brackets for the square root function. I've done something bad, haven't I? What didn't it like? I forgot the 2 behind the caret symbol. That's better. And that should be the length b. Now, same trick. For edge C, we're focusing on the distance between A and C. Beg your pardon, between A and B. What was I talking about? Difference in the y values. And close the square root function. There's my distances. Now for the semi-perimeter. We need to add those 3 distances and divide by 2. That's the value of S. And finally for the area, we want the square root again. And it will be the value of S multiplied by S subtract A multiplied by S subtract B multiplied by S subtract C. Finally, close the brackets for the square root function. And the area of the blue triangle is 10 units. Now, I should be able to copy those formulas directly downwards and then enter a new set of numbers. So I'll go, again, 0, 1, 2, and 3 just refers to 3 points around a triangle. So I will go 0.9, 4, then I'll go up to 13, 7, and then I'll go to 9, 8. And I have the area of the red triangle is 8 square units. So let me just put some boxes there to make that look neat. And that's our distances of each side and our areas of the 2 triangles. I could extend this table downwards for as many rows as I like for as many triangles as I want. Now I'm just going to go back to, here we are. This is where I started from. So let's confirm. I'm having trouble making this fit. Finally, that's a bit better, isn't it? So blue triangle, 10 units of area. Check. Red triangle, 8 units of area. And if you check the distances here for each of these, they match the distances around those triangles. That's it. Thanks for watching.